everyone, this is the second video for lesson 5.3, Proving Polynomial Identities. In the last video we stopped here, and today we're just going to be solving even more questions in order to make sure that you understand the concept clearly and make sure that you are able to solve any question that you have to solve. Okay, let's do question number 14 in page 273. So I'm going to try and expand this into this, okay, into what is in the left side. So I'm going to, first of all, we can see here that we have a special product, so I'm going to try and write a special product here as well. So we will try and find out if x squared plus 4x plus 4 can be rewritten as x plus 2 squared. So we know that a plus b squared is a squared plus 2ab plus b squared. This is an important concept to already be familiar with. So let's see if this can be rewritten as x plus 2 squared. So a squared is x squared, so that means that a is x, plus 2ab, a we already know it's x, 2 times what is 4, 2, plus the square root of 4 is 2, so now we can be sure that b is 2. So we will rewrite this into x plus 2 squared times x cubed minus 3x squared plus 3x minus 1 and x plus 2 squared times x minus 1 cubed. We know that we can rewrite x minus 1 cubed into x minus 1, x plus 1, and x minus 1. This is the same as x minus 1 squared. So we're going to rewrite this into x plus 2 squared times x cubed minus 3x squared plus 3x minus 1 times squared. And then the expansion of x minus 1 squared is a squared, which is x squared minus 2ab, so minus 2x plus b squared, which is plus 1, and then times negative 1. So we're going to try and multiply these together, and we're going to use the distributive property. So it will be x times x squared minus 2x plus 1 minus 1 times x squared minus 2x plus 1. And our answer will be x plus 2 squared times x cubed minus 3x squared plus 3x minus 1 times x plus 2 squared times x cubed minus 2x squared plus x minus x squared plus 2x and minus 1. So when you will simplify this, you will get x plus 2 squared, x cubed minus 3x squared plus 3x minus 1, x plus 2 squared. The like terms are negative 2x squared and negative x squared, as well as x and 2x. So when you add them, you will get x cubed minus 3x squared plus 3x minus 1. And now, are they equal? Yes, in fact they are. So we have proven that this is an identity, and we have determined that it is an identity since they are equal to each other. So this is an identity. Let's do one more question, which is just like the one before. So we have to try and write x squared plus 6x plus 9 into x plus 3 squared, and we have to rewrite x plus 1 cubed into x cubed plus 3x squared plus 3x plus 1. And if we will be able to do both of them, then they will be equal, and we will be left off with the conclusion that this is an identity. So first, we will have to try and write this into x plus 3 squared. So it will be x a squared, which is x squared, plus 2ab, so 2 times x times 2 times what is 6, 3, and the square root of 9, which is 3. This proves to us that b is 3. And then we have to rewrite x plus 1 cubed into x plus 1 times x plus 1 times x plus 1, just the same as x plus 1 squared times x plus 1. And then we expand x plus 1 squared into a squared plus 2ab plus b squared, which will be x squared plus 2x plus 1 times x plus 1. So let's write, this is x plus 3 squared. So let's write this and this next to each other, and then simplify even further. So it will be x plus 3 squared times x cubed plus 3x squared plus 3x plus 1 equals x plus 3 squared times x plus 2x plus 1 times x plus 1, and then you have to multiply these two in order to try and get something like this. So it will be x times x plus, this is x squared, in fact, I think I forgot to write that, x times x squared plus 2x plus 1 plus 1 times x squared. No need to write plus 1, we already know 1 times anything is the same, so plus x squared plus 2x plus 1, which will be x cubed plus 2x squared plus x squared plus 2x plus 1. And when you simplify, you will get x cubed plus, you add the like terms, which are 2x squared and x squared, and x and 2x, which will be x cubed plus 3x squared plus 3x plus 1. And then when you rewrite all of this, you will get, let's write it in a different color, you will get x plus 3 squared times x cubed plus 3x squared plus 3x plus 1 equals x plus 3 squared times x cubed plus 3x squared plus 3x plus 1. These are equal, which means that this is an identity. Now, I have realized that this might have confused you, how I did this in this way. I should have written it in a more organized way, but simply what I've done is I simplified this into a plus b squared. Why? Because here we have a special product, x plus 3 squared, and we have to try and duplicate that in this side. So, which I found out that it's x plus 3 squared. Then for x plus 1 cubed, I have to try and expand it into x cubed plus 3x squared plus 3x plus 1. We know that x plus 1 cubed is the same as x plus 1 times x plus 1 times x plus 1, which is the same as x plus 1 squared times x plus 1, and then I just expanded this special product and then multiply this binomial with this trinomial and got x cubed plus 3x squared plus 3x plus 1, and then I found out that these are equal, which means that it is an identity. Thank you for watching. This was the last part for lesson 5.3. I hope you understood and benefited from this video. If you have any questions, leave your questions down below, or you can email me at educology.help@gmail.com. Any recommendations of any lessons that you would like me to explain, I would be glad to do so. So thank you and have a great day.